All right, ready to dive in. Today we're tackling something kind of mind-bending, electromagnetic waves.
You know, those invisible forces behind, well, almost everything.
Exactly, and we've got a ton of research on
Oh,
this.
yeah, papers, infographics, even some historical stuff about how these waves were first
Should
discovered.
be a fascinating deep dive.
You might be thinking, waves? Like out in the ocean. How exciting can that be?
Right.
But trust me, we're talking about the forces behind rainbows, X-rays, even the very signals letting us have this conversation right now.
It's like we're constantly surrounded by these waves, but most of us have no idea.
Right. It's like suddenly realizing, wait, I'm breathing air. Been doing that my whole life, never thought about it.
Perfect analogy. So first things first, what are these electromagnetic waves?
Okay, so imagine you've got a rope, right? And you shake one end of it really fast.
Okay, I'm picturing it, the ropes making those up and down, like ripples.
Yeah. Well, electromagnetic waves are kind of similar, but instead of the rope moving, it's electric and magnetic fields.
Oh, okay, so it's not a physical thing that's waving.
Nope, pure energy fields. And they're not moving up and down, but vibrating perpendicular to each other in the direction the wave is traveling.
Whoa, so it's like 3D waving? That's hard to even visualize.
It is. But the key takeaway is it's these fields vibrating, and that creates the wave.
And these waves are traveling at the speed of light. That just seems impossible.
It is mind-bogglingly fast, and that's part of what makes them so powerful, right? Now, get this. Just like on a piano, you've got different keys making different notes.
Uh-huh.
These waves come in a whole range of what we call frequencies, kind of their own musical scale.
So the electromagnetic spectrum is like a giant cosmic keyboard.
You got it. And it plays everything from the deep bass of radio waves to the super high-pitched gamma rays.
Wow, and everything in between.
Everything. Microwaves, infrared, visible light, the whole shebang.
Okay, so this spectrum covers a lot of ground. Let's start with the low notes then, radio waves. What's special about them?
So radio waves, they're kind of the marathon runners of the spectrum,
Hmm.
able to travel incredibly long distances.
And they can go through stuff like it's nothing. That's why you can pick up a radio station miles away, even in a tunnel. Always bugged me how my phone signal dies underground, but the radio's fine.
Yep, radio waves just slip right through many materials. It's awesome.
So radio waves are how we get, well, radio and TV broadcasts, that's obvious, but what's something most people don't realize about them?
Well, here's a fun fact. Radio waves don't just travel in a straight line. They go out in all directions from their source.
Like a sphere expanding outwards.
Yeah. Think of dropping a pebble in a pond. Those ripples spread out in a circle. Radio waves do something similar, but in 3 dimensions.
Ah, so it's not just about sending out the signal, it's about being able to like locate it too. So that's important for radio, sure, but what about other uses?
It's crucial for astronomy. We use radio telescopes to pick up these faint signals from distant galaxies, and that tells us a ton about what those galaxies are made of, how they're moving, all kinds of stuff.
It's like listening in on the universe's secrets. Never thought of radio waves as being that profound.
Right. And we're just getting started. Want
Yeah.
to turn up the heat a bit and move on to microwaves.
Speaking of heat, can't forget about those leftovers in the microwave. But besides nuking my food, what else are microwaves good for?
Oh, microwaves. They're the multitaskers of the electromagnetic world. They're shorter in wavelength than radio waves, which gives them a bit more energy.
Hmm.
And we use them for communication, radar technology, and of course the microwave ovens we all know and love.
Oh yeah, those are lifesavers. But what makes them so good at heating things up?
It all comes down to their interaction with water molecules, you see. When microwaves hit those water molecules in your food,
Yeah.
they make them vibrate like crazy. And that vibration generates heat.
Okay, makes sense.
Yeah.
But there's always that nagging question, are they safe? I mean, they're zapping my food with invisible waves.
Good point. Microwaves are what we call non-ionizing radiation, meaning they don't have enough energy to knock electrons off atoms, which is what can lead to things like cancer.
So X-rays and gamma rays, those are the ionizing kind, but microwaves are okay.
Exactly. It's probably still not a good idea to, like, press your face against the microwave door while it's running, but the amount of radiation that actually reaches your food is very controlled and safe.
That's reassuring. So it's not going to give me superpowers.
Probably not. It's all about understanding how these waves work, using them responsibly.
Right, makes sense. So let's shift gears a bit to something we experience every day but can't see, infrared.
Infrared, those are the heat waves, right?
Yeah, like I can't see the waves coming off a hot stove, but I can definitely feel them.
You got it.
Hmm.
Infrared waves are nestled right between microwaves and visible light on the spectrum,
Okay.
and you experience them primarily as heat.
Right, makes sense.
Think about the warmth you feel from the sun, a fire, even your own body. That's infrared radiation in action.
Wait, my body is giving off invisible heat waves. That's kind of trippy.
It is. And besides making us feel toasty, infrared waves have a ton of cool uses. Your TV remote uses infrared to communicate with the TV,
Oh, yeah.
and night vision goggles, those work by detecting the infrared radiation given off by objects, even in the dark.
Whoa, wait a minute. Everything's giving off these infrared waves, even in total
Yep.
darkness.
Anything with a temperature above absolute zero, which is basically everything, emits some level of infrared radiation.
So the hotter something is, the more infrared it emits. That's how those thermal imaging cameras work then? The ones that show, like, heat signatures.
Exactly.
Yeah.
Pretty cool, huh? But speaking of things we can see, let's talk about visible light, the rock star of the spectrum, at least for us humans.
Ah, yes. Visible light. Finally something we can actually see.
Right. And what we see as color is actually just different wavelengths of light.
So, like, shorter wavelengths are bluer, longer wavelengths are redder.
You got it. That's how rainbows work. The water droplets in the air act like prisms, splitting that white sunlight into all its different wavelengths.
That's so cool. Is there an easy way to remember the order of the colors in a rainbow? It's ROY something, right?
ROYGBD. Red,
Yeah.
orange, yellow, green, blue, indigo, violet, like a little mnemonic rainbow right there.
ROYGBBV, I'll remember that. And white light is just all those colors mixed together.
Exactly. It's like the ultimate color mashup.
Mind-blowing. Okay, so we've got the colors covered. What comes after visible light on the spectrum?
Next up, we have ultraviolet, or UV rays. Those are the ones that give us tans and sometimes sunburns.
Ah, UV rays. Always got to remember that sunscreen. But besides sunburns, what else should we know about these guys?
Well, UV rays are shorter in wavelength than visible light, so they pack a bit more energy.
Oh, yeah.
That extra energy can be both good and bad. Overexposure can be harmful, for sure, but small amounts of UV radiation are actually crucial for our bodies to produce vitamin D.
So it's like a double-edged sword. We need some, but too much is bad news.
Precisely. It's all about finding that balance, right? Now, are you ready to move into the realm where things start getting a little more intense? We're talking X-rays.
X-rays, those are the ones that let doctors see inside our bodies, right? Like superhero vision.
Uh-huh, exactly. And what makes X-rays so special is they have even more energy than UV rays, and their shorter wavelength allows them to penetrate a lot of materials.
So that's how they can pass right through skin and muscle but get blocked by bone, which is why we get those cool skeletal X-ray images.
Precisely. But there's a reason we wear those lead vests during dental X-rays.
Yeah, they always feel kind of ominous, like I'm about to be exposed to something dangerous.
Well, there's some truth to that. X-rays, unlike microwaves, are a form of ionizing radiation, meaning they do have enough energy to knock electrons off atoms.
Oh, so that's where the potential danger comes in.
Right, overexposure to X-rays can damage cells, so doctors are always careful to limit the amount of exposure.
Makes sense. So X-rays are incredibly useful, but need to be handled with caution. Good reminder. Okay, on to the last stop on our electromagnetic journey. Gamma rays. What can you tell us about these mysterious rays from space?
Gamma rays are the rock stars of the spectrum. Shortest wavelengths, highest frequency, highest energy, they're the heavy hitters.
Wow, sounds intense. Where do they even come from?
They come from some of the most extreme events in the universe. Supernovae, black holes, even radioactive decay here on Earth.
So things that would probably vaporize us instantly.
Pretty much. But despite their potential danger, we've found ways to use gamma rays for good, too.
Like what?
They're used in cancer treatment, to sterilize medical equipment, even to study the universe itself. Pretty amazing, right?
So we've gone from radio waves that can travel for light years to gamma rays that are born from exploding stars. The electromagnetic spectrum is wild.
It is. It really makes you realize there's so much more to the world than what we can see. But before we get too philosophical, let's talk about how the wavelength of these waves actually affects how they, behave, how they interact with stuff.
Okay, I'm ready to get a little technical.
Yeah.
Always wondered how that wavelength stuff makes a difference.
It's kind of like, imagine you're trying to push a shopping cart, right?
Yeah.
But on different surfaces, first you're on smooth pavement, easy peasy,
Yeah, no problem.
but then, bam, you hit gravel, or even worse, sand.
Ooh, yeah, suddenly it's a lot harder to push. The wheels might get stuck.
Exactly. So think of the shopping cart as our electromagnetic wave, and the terrain is like the different types of matter it encounters.
Okay, I'm following.
The wavelength of the wave is like the size of the wheels on that cart.
Interesting analogy.
Longer wavelengths, like those radio waves we talked about, they're like having big old wheels. They just roll over most obstacles.
And shorter wavelengths, like X-rays, are like tiny wheels. They get bogged down easier, but can squeeze into tighter spots.
You got it. That's why radio waves can travel so far, even through walls. Their wheels are big enough to handle it.
While X-rays, with their tiny wheels, can slip through our bodies but get stopped by dense bone.
Right?
Yeah.
Exactly. It's all about how the wavelength, that wheel size, interacts with the terrain of the matter.
So that's why some waves can travel through stuff, others can't. It all depends on their wavelength and what they're trying to move through.
Precisely. And this interaction, it's what makes electromagnetic waves so incredibly useful.
Oh, yeah, we've seen that already. Communication, medicine, even exploring the universe.
We figured out how to harness these waves for so much, it's pretty remarkable.
It's like our whole modern world relies on these invisible forces. We use them to make calls, watch TV, diagnose illnesses.
And cook food, don't forget about those microwaves.
Uh-huh, right. It's amazing how much we depend on something we can't even see.
It really speaks to human ingenuity, how we've taken these invisible forces and learned to manipulate them to make our lives better.
It's like a testament to the power of science, understanding the universe to create amazing advancements. But, with all this talk about the benefits, we got to acknowledge some of these waves can also be a little risky.
Oh yeah, for sure. We touched on that with UV and X-rays.
Right. Too much UV exposure can cause sunburns, skin damage, even skin cancer, and X-rays, well, too much of those can damage cells, too.
Absolutely. So what can we do to protect ourselves?
Well, for UV, it seems like common sense is key, right? Sunscreen, hats, sunglasses, all that.
You got it. And limiting exposure during peak hours, being mindful of reflective surfaces like snow.
And what about X-rays? I know doctors take precautions, but is there anything we should be aware of as patients?
It's always a good idea to talk to your doctor. They can explain why the X-ray is needed, how much exposure you'll get, any steps they take to minimize the risks.
Right, informed consent is always important. But what about all the other sources of electromagnetic radiation we encounter daily? Cell phones, Wi-Fi, power lines, there's a lot of talk about those.
That's a tricky one. A lot of debate around those, and it's important to, stick to credible scientific sources, not get caught up in hype.
Right, so what's the current scientific consensus on those? Are they harmful or not? It seems like everyone's got a different opinion.
The research is ongoing, but so far, there's no conclusive evidence that exposure to those low-level electromagnetic fields from everyday devices causes any real health problems.
So it's more about staying informed, being cautious, but not panicking.
Exactly. We need to be smart about it, make decisions based on good science, not just fear.
It's all about finding that balance, right? Appreciating the amazing things these waves do for us, but also understanding there are potential risks and making informed choices.
Perfectly said. This deep dive has been a wild ride. We've learned so much about these invisible forces, the different types, how they work, what we use them for.
And even how to stay safe.
It's incredible how much these invisible waves shape our world and our understanding of the universe itself.
It really highlights how much we can learn about the universe by studying these waves, figuring out what stars are made of, how galaxies are structured.
And we're doing all this by studying something we can't even see. It's pretty mind-blowing.
Absolutely. So, as we wrap up our deep dive into the world of electromagnetic waves, what's one final thought you want to leave our listener with?
It really shows you the power of science, who would have thought that by studying these things we can't even see, we'd unravel all these mysteries of the universe?
From tiny atoms to those giant galaxies, it's incredible. What's one thing about these waves that still just blows your mind?
What always gets me is that the entire universe is just buzzing with these waves, right? Carrying information across such vast distances over billions of years.
It's like we're just now tuning into this cosmic conversation that's been going on forever. So what do you think the future holds for, our understanding of electromagnetic waves? Where do we go from here?
Well, we've seen how many uses they have, so imagine the potential. What new tech could we create? What else could we discover by, say, studying radio waves from those distant galaxies? Or those gamma rays from black holes?
Those are some big questions. It seems like we're just scratching the surface of understanding these waves.
I think so. There's so much more to learn, more to discover. Who knows what breakthroughs are waiting for us? Maybe we'll figure out how to harness gamma rays for good or, invent some way to see the universe in ways we can't even imagine yet.
The possibilities really are endless. I think we've given our listeners a lot to ponder today. From radio waves to gamma rays, we've explored the whole spectrum.
It's been a fascinating deep dive.
Agreed. And to everyone listening, remember, the universe is full of wonders, both seen and unseen. Keep exploring, keep asking questions, and never stop learning. Until next time.